Hello, welcome along to naming some organic molecules. So it's really important you can get this sorted as soon as you can in the AS course. There's a huge amount of organic chemistry in OCR, which you've got to get right, both for AES and A2. Unless you can name the molecules, you're kind of going to hit problems early on. Often the questions will start with giving you the name of the molecule and ask you to do something with it. So unless you really know what you're talking about, you've fallen at the first hurdle really. So let's get on. What we're going to do is we're going to start with some basic ones and then move on to the main functional groups that you meet at AS chemistry. So the first thing you've got to get sorted is the number of carbon atoms in the longest chain, which bears a functional group. This is known as a stem, and it also includes a prefix which shows position identity of any side chain substitutes. So this is looking at your carbon backbone, basically. You've got to get that sorted, otherwise you're going to end up with some crazy names. So we're going to start off by trying to find the longest chain in a number of molecules. So have a look at these 4 molecules here, and we're going to try and find the longest chain. Now initially they may all seem different molecules. In fact, they are all 5 carbon chains, 5 carbon atoms in a chain. So let's have a look. We've got 5 going on there, 3, 4, 5, like so. You've also got 5 going there, 5 like that, and then you've got 5 like that. So they are all pentane, exactly the same molecule. Remember, carbon-carbon single bonds, you have free rotation around those. So they always give you, these can all rotate around like so. So it doesn't matter that they're all higgledy-piggledy like that. You can, if you think about it, take both ends. So you could take that end, and you could pull it, and you'd end up with it looking like that one. So the easiest way to do it is to get a pencil, quickly just do a quick line, and if you can draw a line without it breaking or going off like so, then you've got one chain, and that's going to give you your starting point. Okay, so what I'd like you to do is have a go at trying to find your longest chain possible for these 3 examples. So pause it for a minute, and once you've had a bash at it, restart it up again. Okay, so let's tackle this first one. Hopefully you can see that my longest chain here, remember I want to draw the longest line possible, is 1, 2, 3, 4, 5, 6, like so. How about this one? Well, we can start this in 1, 2, 3, 4, 5. And then finally 1, 2, 3, 4, 5, 6. Like so. So once you've got your starting point, what do? Well, you count out the number of carbon atoms and you learn this table basically. This goes up to 10 carbon atoms. So for the last one I had 5, so I would be looking in this area here, 5 carbon atoms. That means that I am looking at it being pent. I'm going to start in the first part of the name. That's going to be my starting point, pent. Now it was an alkane that we were looking at, so that gave me pentane that we were looking at on the previous slide. However, the end will change. This end will change depending on the functional groups I have present. This is the one you've got to know really well. So make sure you learn that table. So as I mentioned briefly on the last slide, you've also got the ending to the name, which tells you the functional group. Now, in the last one, they were alkanes, so we had in our table ane. So when we were looking at those 4 examples, they were all pentane. However, if they had a double bond, they would end in ene. So if I spotted a double bond, it would end up being pentene, and so on. We're going to look at each of these as we go through. The only one we're not going to touch on are the alkynes. These actually have carbon-carbon triple bonds in. They're not covered at OCR, but it's worth knowing that if you do have a molecule which has a carbon, it's going to be an alkyne. The other thing worth noting, which we will look at, is you also often have to put the position of the functional group there as well. So you often need to say where the position of your carbon-carbon double bond is, or your alcohols on. Not always necessary, which we'll look at a little bit later on, but often you do actually have to have a number in there as well. So once you've found your longest carbon chain, you need to think about how you're going to tackle any side chains coming off of it. Dead easy to do, as long as you've learnt that table on the slide a while ago. If it's got one carbon, rather than it ends up being, it starts with a meth, well, it just becomes methyl. Equally, F is for two carbons. Well, if it's a CH3CH2 group, it becomes ethyl. So you just put YL at the end of it. So dead easy as long as you know that first table. Just a couple of minor points. Side chains, we put them in alphabetical order. Normally they also have to be given a number as well. And if we do have, say, two methyl groups coming off, we can pop them together and call it a dimethyl group, rather than the name becoming really cumbersome with say 2-methyl, 3-methyl. You can pop them together to call it 2,3-dimethyl and so on. Okay, so how do we put everything together? Well, you got to remember to add your hyphens and commas in your names as well. So if you have a number, you need to put a hyphen between the number and the name. So, for example, for this one, it is telling me 3-methylheptane is telling me that the methyl group is on carbon number 3, and the longest chain that I've got from the heptane is going to be 7 carbons long. How about this one here? I've got two numbers, so I've got a dimethyl group there. It's butane, so I put a comma between those two numbers, the 2 and the 3, and then a dash between the 3 and the dimethyl, so I've got everything going on in this guy. And then the butane is, of course, telling me that I've got 4 carbons. So we can sketch this one out. If I just move that up there, we're going to have 4 carbons, 1, 2, 3, 4, and then a methyl group coming off carbons number 2 and 3, and the rest are going to be hydrogens, like so. Okay, so here's a couple of examples for you to have a go at. So try naming these two and see how you get on. So let's tackle that first one. So where's my longest chain going to be? Well, it's going to be 1, 2, 3, 4, 5. So my longest chain is 5, which means it's going to be pentane, because of course it's an alkane. However, I need to think about this guy here. That's a CH3 group, which is of course a methyl group. Now we need to use the lowest number possible. Doesn't matter in this case, because whichever end I start counting from, this is actually going to be carbon number 3. So the name is 3-methyl pentane. How about this other one here? Well, I've got 1, 2, 3, 4, 5, 6 carbons, so it's going to be hexane. There I've got a methyl group coming off, so this guy is going to be 2 dash or hyphen methyl hexane, because that of course is going to be carbon number 2. I'll start from that end. I could, if you think about it, start from this end here. However, when we look at the rules, we'll note that we should use the lowest number possible. Let's have a go at that example and see how you get on. Right, so it looks more complicated, and indeed it is. So let's have a go. Let's try and find my longest chain. We're going to start here. 1, 2, 3, 4, 5, 6. So it's going to be a hexane again, but remember we need to take account of that guy and that guy. I'm going to count using the lowest numbers possible. So I'm going to use, if I use that as being carbon number 1, that's 2, that's 3, 4, 5, and 6. It would end up being 3, 4 dimethyl hexane. How about counting the other way? So that's 1, 2, that's 3, that's 4, that's 5, and that's 6. Well, again, it would be 3, 4 dimethyl hexane. So it doesn't really matter which end I start with. So here we go, 3, 4. Remembering to put commas between my two numbers. Dimethyl. And it's again a 6 carbon chain, so hexane. Right, so we're going to tackle some alkenes now. Remember with alkenes, they contain the carbon-carbon double bond. So the first thing you need to watch out for is your principal carbon chain is the one that contains the carbon-carbon double bond. So don't worry about whether it's the longest or so on. Find the one which has your carbon-carbon double bond. Obviously, make sure whichever one does is the longest one possible. That then becomes your principal chain. You then number it, making sure to show the position of the carbon-carbon double bond using the lowest number possible. So, for example, for this one, you can see I have got 1, 2, 3, 4, 5 carbons. However, if I start from this end, I've got, again, obviously the 5. But using these numbers, I would be using the 2 to position my carbon-carbon double bond. In red, I'd be using the number 3. So I'd be obviously using these numbers here. Again, once you've determined how you're going to number your carbon-carbon double bond, you then label your side chains. So have a bash at doing those couple of examples there. Right, so hopefully for the first one, we've said that it's a 5 carbon chain. The carbon-carbon double bond is on carbon number 2, so it becomes pent 2-ene. Pent because I've got 5 carbons, 2 because the carbon-carbon double bond is on carbon number 2. How about this guy here? Well, it's going to be a 4 carbon chain because this guy here is a branch coming off of it, so it's going to be based on bute. If I start here, 1, 2, 3, 4, so I can use bute 1-ene, and the methyl group is coming off carbon number 3, so the name is 3-methyl bute 1-ene. Right, so our next little section is going to be on halogenoalkanes. So these guys contain a carbon atom bonded to a halogen. So X can equal fluorine, bromine, chlorine, or iodine. And you use the suffix fluoro, bromo, chloro, or iodo and give the position of where it is. So if we have a look at this example here, you can see I've got a 4 carbon chain there. I've got a chlorine on carbon number 1, and therefore it is 1-chlorobutane. So why don't you have a bash at doing the other ones there? So for this one here, you can hopefully see I've got 3 carbons in a row there. So it's going to be based on prop for 3. I have got an iodine on carbon number 2, so it's going to become 2-iodo propane. How about this one down the bottom here? Well, I've got 2 carbon atoms and I've got a bromine on it. Because I've only got 2 and I've only got 1 bromine, it doesn't matter about a number, does it? So I could just call him bromo ethane. Because he's going to be on, doesn't really matter, carbon number 1, he's got to be on that one, so numbers are meaningless in this case, so just bromoethane. Okay, alcohols. So alcohols have an OH group. So when you meet these guys, you will have a carbon atom and an OH group like so. So how do we name these? Well, rather than if it was an alkane, we will end it, the last letter will be an E. We change that E to an O for an alcohol. And we need to insert the number between the just before the O to tell me where that alcohol is. If by chance you ever meet a molecule which has got two different functional groups in it, then you can change, rather than having the O at the end, because you may want to end it to tell the other functional group, you can use hydroxy at the start of the name to tell you where the alcohol is. So have a go at doing those two and see how you get on. Rightio, well this first one, hopefully you can see I've got 4 carbons in a row, so it's going to be bute, and I have got the OH group coming off carbon number 2, so it's going to be butan 2O. For this next one, let's have a go. So I have got 1, 2. Remember, this guy is a branch coming off there. So that's 3 and that's 4. So again, it is a butanol of some sorts. It looks like if I take the position of the alcohol group and use the lowest number possible there, I'm going to start from the other end. So 1, 2, 3, 4 in that case, and let's cross through those. So it's going to be butan 2O, like so, but let's not forget that methyl group, so it's going to become 3-methyl butan 2O. Okay, so aldehydes next. Aldehydes have this functional group here. So it's got a carbon, double bond O, and then an H. So it's always got to come off the end. Therefore, you don't need a number because it's always going to be at the end of the molecule. So those are 2 examples for you to have a go at doing. See how you get on. I'd recommend you probably do the last one first because that's the easiest one. So let's tackle him. Right, so this last one I have got 1, 2, 3 carbons. So I'm going to start off with it being prop. It ends in al because it's an aldehyde, so it just becomes propan al, like so. And again, it's got to be on the end. How about that next one? Well, let's have a look. Carbon number 1 is always going to be where the aldehyde is. So let's number those. 1, 2. That, remember, is a branch. So that's 3 and that's 4. So it's going to be based on bute. Tanal. The al is on carbon number 1. I've got to deal with that methyl group, which is actually coming off carbon number 3. So the full name is 3-methyl butanal. So ketones. Ketones have a C double bond O again. However, you have that group. So you have a carbon which has got 2 carbons either side of it with a C double bond O there. So how do we name them? Well, we replace the E with an own at the end, and you do generally need a number to tell you the position of that ketone. So there are 2 to do. Have a bash at the second one first perhaps, because it is slightly easier. So what have you got here? So let's have a look. I have got 1, 2, 3, 4 carbons. So it's going to be bute. Now, do I need a number? Well, for 4 carbons and it's a ketone, it's got to be on those middle 2 carbons. So in fact I don't. I can just call him butanone. How about that top one? Well, he is a little bit trickier. So how can I do it? Well, how many carbons do I have there? I'm going to start off this. So 1, 2, 3, 4, 5 carbons there. Remembering again, he is a side chain coming off. I need to use the lowest number possible for my ketone group, which is why I've started that end. So, going to be 5, so it's going to be based on pent. And 2 one, because I do need the number here. I've got a methyl group, and that methyl group is coming off carbon number 3, so it becomes 3-methyl pentan 2 one. So the final ones you need to be able to do are carboxylic acids. Carboxylic acids, when you meet them, oh, you may have already, they have that group coming off. Always on the end, therefore you don't generally need a number. The way we name it is we put oic instead of that E on the end of the alkane name. Let's have a go at doing those two. So this first one, the carboxylic acid has got to be on carbon number 1. So 1, 2, 3, 4, 5 carbons. So it's going to be pentanoic acid. But I've got a methyl group coming off carbon number 3 there. So it's going to be 3-methyl pentanoic acid. Right, for that next one, I've drawn it up for you, so it should have appeared, just so that you can see where the longest chain is. So if you have a check of that, my longest chain is actually there. May not have come out particularly well there. Let's do it in a different colour. So it starts off with that carbon there, goes all the way down there and along there. So that is going to be a 1, 2, 3, 4, 5 membered chain going along there. And I've got a methyl group coming off carbon number 2 and a methyl group coming off carbon number 3. So the name becomes 2, 3 dimethyl pentanoic acid. Because I've got your pentanoic acid must be on carbon number 1, and then you've got your 2 methyl groups coming off there and there on carbons number 2 and 3. Right, so 3 examples for you to have a bash at doing, and we'll see how you get on. So the first one is, of course, a halogenoalkane, because I've got a bromo group coming off of it. 3 carbons in a row, so it's going to be propane. The bromo is coming off carbon number 2, so he is going to be called 2-bromo propane. Next one, that group is, of course, my aldehyde group. 3 carbons again, so it's propanal, but I've got a methyl group coming off there. The aldehyde must be carbon number 1, that's 2, that's 3, so he becomes 2-methyl propanal. This one, again, 3 carbons, not being very imaginative here. Is an alkene, because I've got a carbon-carbon double bond, so he is actually going to be called propene. Notice I don't need to worry about a number there, because he's always got to be between those 2 carbons, whichever way I draw it. So If you wanted to put a number, he'd become pro-1ene, but you wouldn't put a number there because he's not necessary. It's always got to be on the first carbon. So 3 more examples for you to have a go at, and then see how you get on. So first one is of course an alcohol. I've got an OH group there. I've got 4 carbons in a row there, so it's going to be based on butanol. The alcohol is coming off carbon number 1, so he becomes butan 1-O. Again, for this one, 4 carbons, but now my alcohol is coming off carbon number 2, so this guy would become butan 2-O. And the final one, I've got that one there, so I've got a ketone group coming off, so it's going to end in -one. I again have 4 carbon atoms, so he's becoming butanone. Notice I don't need a number there because he's got to be on that carbon to be an ketone. Okay, couple more just to finish off with. Right, so for that first one, I have got obviously a carboxylic acid, and I have got, that's my longest chain there. It's got to be the one, the longest one with the carboxylic acid in it, to include that. So I have got 1, 2, 3, 4, 5 carbons there. So it's going to be pentanoic acid with a methyl group coming off carbon number 3. So 3-methyl pentanoic acid. And for this final one, there we go, I've got 4 carbons to include my carboxylic acid, so it's going to be butanoic acid with a methyl group coming off carbon number 2, so it becomes 2-methyl butanoic acid. Okay, so those are pretty straightforward examples, just to get you going really. As you go through the course you will meet more complex examples, but as long as you can get the basics at this stage, that's the important thing as you start your journey through AS chemistry.